All right, so starting our last unit, this is another one of those units that takes smaller topics and puts them in the same unit overall. So this unit, we're going to focus on soil, glass, and arson analysis and evidence that we'll look at. So today we're going to focus on soil. And as always, you have the vocab list at the front of your notes that you can find in Canvas. Throughout today, we're only covering like the first 4 vocab terms. All right, so looking at soil as evidence. Soil is one of those important pieces of evidence that we can find because we're going to find soil basically anywhere you would walk. Because it is everywhere, and remember, when you walk, whenever your shoes contact the ground, some of that dirt and soil is going to stick to the bottom of your shoes. And whenever you walk, it will transfer to whatever surface you're walking on. So since soil's everywhere, it's easily transferred. It's very small particles. That refers back to that Lockhart's principle, where anytime there's contact between 2 materials, there's going to be a transfer of materials. When looking at soil, we want to be able to compare samples to known locations to establish a link or relationship. So just the fact that we find soil doesn't give us a whole lot of details. But if we find soil on a suspect's shoe that matches the same type of soil at the victim's house, that can link them to that crime scene. But we have to have that comparison of samples. And the more characteristics about that soil that can be matched, the greater the probability of common origin, or the greater match it is. So with soil, we're going to look at different factors like what it's made of, particle size, color, any chemicals that might be in there. The more factors we find that match up, the more likely those samples of soil came from the same source. This comparative analysis looks at both physical and chemical properties of the soil. So physical properties, remember, we can observe or measure without doing anything to the soil, whereas chemical properties are going to be some form of chemical reaction that occurs. So some of the things that we look at would be like the density of the soil. Remember, density is the mass over volume of a sample. This deals with particle size as well. Whenever we have smaller particles, it tends to be a more dense sample. Some types of soil, depending on what minerals are in the soil, might have magnetic properties. Like if it is very rich in iron, it will have magnetic properties. The composition of the soil, what it's made of. So this might be the different elements it's made of. If there's anything else contained within the soil, like roots, seeds, things like that. We can also test like the pH of the soil. We can test the amount of like nitrogen or phosphate and things like that in the soil as well, which are going to go along with those chemical properties. So looking at soil, soil is one of the most common materials in the world, and soil is going to be a mixture. So if you think back to Chem 1, mixtures are not chemically attached to one another. It's like if you're cooking, you throw everything in a bowl and you stir. So soil is a mixture. They're not chemically attached to one another. It's just all the different parts of soil stirred together. But it's a mixture of different sized mineral grains from the weathering of rock and organic material from the decay of vegetation animals. So it's not just rocks, dirts, and small particles. It is going to have like vegetative matter, like roots, seeds, leaves. It could have anything from animals like hair, fecal matter, and different things like that as well. And there are different types of soil, and the proportion of sand, silt, clay, and organic matter determines what soil type we have and its properties. So how we can tell what type of soil we have is by using the soil triangle that is down here. And this is something that you would have seen in earth science. If you have already taken APES, you've seen this at some point in time. But this triangle, it basically has three axes. One that is going to show us the percent clay, that's this left side of the triangle. The percent silt, which is that right side of the triangle, and percent sand, which is on the bottom. Remember that percentages of a sample should add up to equal 100. So we might be given a sample of matter, and it tells us that it is 20% clay. Let's do 60% silt. And then that other 20% is going to be sand. And I apologize for my handwriting. I'm having to write with my mouse. So notice that the percentages do add up to equal 100. How we read the soil triangle to figure out what type of soil this is going to be is you're going to match up all of those axis lines. And one thing to note is our axes, the numbers, it's like clay, the numbers are vertical, but for silt and sand, the numbers are tilted. That kind of gives you an idea of which line you're supposed to be reading. So for clay, 20% clay is this straight line, since that's a vertical number. So we're somewhere on this line. That's our clay kind of axis we're looking at. 60% silt. Silt 60% is here. Notice that it is tilted from like the bottom left to the top right. So follow the tilt whenever you're following that number. 60% silt is going to be this line. And then 20% sand, notice that the numbers for sand are tilted up to the left. So you're going to follow the line that goes up to the left. So where all three of these come together, this is silt loam. So this mixture, this would be a type of soil of silt loam. So that's how you're going to read a soil triangle. And this is something that you are guaranteed to see on your test. If you look at your unit study guide, there is a soil triangle with some practice problems like that. So sometimes you'll be given all three percentages and it will ask you what type of soil it is. It's possible that it only gives you two of the percentages and you have to find the third percentage. So if you came across something, I apologize, let me change color. If you came across a sample that said it's 10% clay, 70% silt, and it didn't give you the percentage for sand, well, 10 and 70 is 80, so sand would have to be 20. You could figure out that missing percentage if needed. It could also ask you what is a percentage of clay, silt, and sand that would be considered loamy sand. I just picked one of the smaller ones. So you would have to look on your soil triangle to find that type that it's looking for. Loamy sand is this area to the bottom left of our soil triangle. So you can pick percentages that fall anywhere in this little trapezoid looking shape. So maybe I would just pick a point. So if I pick a point here in the middle, I would say that's probably about 5% clay, about 80% sand, And then the other percentage would have to be about 15 for silt. So you can come up with those percentages that would fall in that area. So definitely take some time to look at your unit review and practice some of those problems. If you're having issues with this, someone who would be a good resource would be Miss E, since this is also included in the APES curriculum. So different types of soil are going to be formed in different ways. And this kind of depends on how the individual rocks are weathered and broken down into those smaller soil particles. So sand is the result of chemical and physical weathering. So remember, with weathering, physical would be like if we had a rock and we hit it with a hammer to break it into smaller pieces. We did not chemically change the material of the rock, we just changed it into smaller pieces. Whereas chemical weathering might be if we use like acid or something to wear down the surface of the rock. Sand overall is made of mostly silicon based. So it tends to be silicon dioxide based. It can have other substances, but that tends to be what sand is made of. Now in our area, we don't tend to have a lot of just sand. We might have more of clay and things like that, that is more rich in minerals, and it may contain other substances. Especially in the organic layer, kind of close to the Earth's surface, where we're going to have vegetation and plant life. We have this dark organic soil that contains a lot of humus or humus, however you would prefer to say it, and it's formed from the slow decay of vegetative matter. So this humus tends to be very rich in nutrients from that decay of vegetative matter. So it tends to grow more plants and things like that. But humus is the organic part of soil made from the decomposition of matter. So it's organic, it is made from living things overall. So this might be fungi that have broken down, logs that have fallen and kind of rotted, and all of those nutrients go into the soil underneath it. And soil composition is going to be different from place to place based on a lot of different factors. So one of those that we look on is climate. So climate, kind of the amount of humidity, moisture in the air, can help determine what type of soil is going to be kind of primary in that area. The parent material, whatever the bedrock underneath the surface is made of, because that's what is broken down and weathered to create kind of the chemical basis for that soil. We can look at what living organisms live in the soil. If there's more living organisms that are breaking down material, it's going to be more rich in nutrients, which can give it different colors and things like that. The topography, this is going to be kind of the landscape of the area. So like a valley would have more nutrients than the side of a mountain due to runoff and things like that. So it could be based off a location. And another is time. How long has that material been there? Did someone come and dig up the ground in the area and bring in new soil and new material? But everything from the rock breaking down to organisms decaying, all of that does take time. So the soil may be constantly changing, even if you're in the same location. All right. So looking at kind of when we do a cross section of the earth, if we take a vertical cross section, it's going to show rather distinct layers called horizons. So here you can see in the picture kind of an outcrop where they have taken and basically dug a large hole. And if you notice up at the top is a little bit darker soil, that's where we have the grass. underneath it is a lighter color. Um, has a little bit of an orange tint to it, but not super orange. Underneath that, it is more orange. And then underneath that, you have more like rocks and boulders that we come across. Each one of these different layers that we can pinpoint, we refer to as a horizon. Excuse me. And each horizon contains a different material. And this is based off of how far under the ground it is, whether living things live in that area, and stuff like that. So up at the very top is that A horizon. You may have also heard this referred to as like an O horizon, where the organic material is. But this A horizon up at the top is mostly topsoil, mostly that humus. It tends to be a darker color. Underneath that, we start getting the clay. So these two kind of orangish layers are mostly clay. So the clay gives it more of that orange color. Particles are smaller. Water doesn't run through these as easily. We might have some of the humus mixed in, especially at the top of it. But this tends to have a lot of the iron oxides that give it that orange color. If you were to like dig to plant something in your front yard, our area is basically on a clay slab. So you would find a lot of clay whenever you go to plant a plant or something like that. Underneath that, we have our C horizon, which is going to be that partially weathered bedrock. So it's going to be more like boulders, rocky, and then underneath that is going to be solid bedrock. So that's going kind of from the surface down to more towards the core, and that bedrock will extend kind of all the way down into the mantle, essentially. And one thing that we will do to analyze soil and to help match it up is we will take soil samples from different locations and use those to help us find where soil originated from. So soil samples can be taken from locations, and they'll even be taken close together. So they might even be taken just a couple of meters apart, or from several meters down into the earth. And soil can be different even if they're in the relatively same area. So if you look at this picture down at the bottom, these are all soil cores that are taken from the same hole. It's just one is taken from closer to the top, and then it's taken from further underneath, and further underneath. So notice that this one all the way to the right is pretty much solid clay. The one next to it is from further down. It starts to get more solid, have more rock in it. The one next to it starts to have more rock in it. The one all the way to the left, definitely more rock. It's not going to stay together and have that clay that kind of sticks the particles together. Samples even taken meters apart from one another can also have differences. So like if we are taking soil samples from a park, if we take a sample from under a tree and then a sample 5 meters away, they can have different compositions. So these different facts allow investigators to kind of prove a common origin of one sample. They cannot just say that, oh, this soil is the same thing that matches soil in the park. They can actually pinpoint it to a more specific geographical area. So looking at how we analyze soil in terms of forensics. The forensic definition of soil is not just going to include like the rocks, the particles, the vegetation. It's also going to include any artifacts that are mixed in with the soil. And artifacts might be any foreign body that would be in the soil. And this actually gives it more of an identity, and it helps us identify soil more and be able to match it up more easily. So artifacts can include things like bits of glass, cinders or ash, pieces of asphalt, paint, metal, little pieces of concrete, bricks, and other man-made products. So anything that might have been dropped, mixed in with the soil, it might come from a roadway, things like that. Those are going to be considered artifacts that are in that soil sample. And artifacts can also include natural products. So it'll look at what type of vegetation, what type of like seeds, roots, and things are within the soil. Any animal matter like hair, fecal matter, things like that. Any like spores, lichens, fungi, anything that is included within that soil sample can be used to further identify it. And a lot of times the presence of these artifacts makes it easier to match a soil sample to a particular location. Because we might have like the same type of soil that we use in our landscaping, but maybe mine has dog hair in it, whereas yours would not. That's something that if someone came and broke in my house and they find soil that's the same as the soil in my flower beds, and then they also find dog hair mixed in with the soil that matches my breed of dog, that kind of gives us an idea that that suspect was at my location. So this can be used to link mud or soil from a suspect's car to clothing, shoes, or other instruments used at a crime scene by that comparative test. So if there are more artifacts in the soil or kind of unique artifacts, it helps us pinpoint the location it originated from. So that is where we will stop today. I would take some time to look through your unit review on anything dealing with soil, and especially look at those soil triangles.